Hello everyone and welcome to David's math class. In this video I will show you a proof of the Pythagorean theorem by the power of a point property in a circle. So first of all, if you are unfamiliar with the power of a point, it states the following. If you have a circle and a point M somewhere, then if you have two lines passing through the circle like this, so that would be AB and CD, then the quantity MA times MB is equal to the quantity MC times MD. And this occurs for any pair of lines that passes through point M and intersects the circle at two distinct points I've marked here. This is the power of a point, and yes, it does work for points inside the circle as well as on the circle. Alright, now that we have this fact in mind, we can move on. So here's the ideal construction. We draw the perpendicular from A to BC and let it be D, like this. So let D on segment BC such that AD is perpendicular to BC. Now, let's observe the following. If we have AD perpendicular to BC, then that means that ADB is equal to ADC is equal to 90 degrees. Now, if in triangle ADB we have that D has measure of 90 degrees, then that means circle ADB has diameter AB. Alright, so I've drawn out the circle for you. I will say that omega 1 is this circle ADB, and for the very same reason, namely that in triangle ADC we have D with a measure of 90 degrees, we have that the circle ADC has diameter AC, and we also construct the second circle. Perfect. And I say let omega 2 be equal to circle ADC, circle with points ABC. Alright, now because AB is a diameter of omega 1, that means O1 lies on AB. Right here, actually I'm gonna draw it in red, like this. And then, similarly, AC is the diameter of omega 2, which means that O2 rests on AC. We'll have it like here. And now the very cool part, since BAC has a 90-degree angle, that means that BA is perpendicular to AC, as well as CA is perpendicular to AB, which means that since BA is L1A perpendicular to AC and CA is O2A perpendicular to AB. So that means that radius 1 is perpendicular on AC, and then radius 2 is perpendicular on AB. That means that AC is perpendicular to omega 1, and then AB is perpendicular to omega 2. And finally, if we just like change this up, we have that CA is perpendicular to omega 2 and BA is perpendicular to omega 1. Did I say that right? It's opposite, sorry. Yes, it's opposite. Like this. Alright. Finally, through the power of a point, we have that power from, actually let me just say that this is omega 1 and this is omega 2. So the power related to omega 1 of point C, that is going to be CA squared, since CA is tangent to omega 1, so it's CA squared, but at the same time it is CD times CD. And then power of omega 2 of B is equal to BA squared, since BA is perpendicular to omega 2, I mean tangent, but I just use the perpendicular symbol, and then this is equal to BD times BC. And look what we're left with. So you have CA squared is equal to CD times BC, and then BA squared is equal to BD times BC. Now you just add this up. So you have AB squared plus AC squared is equal to BD plus CD times BC. And finally, because this adds up to BC, we get that AB squared plus AC squared is equal to BC squared. And we're done. Like this. Thank you guys so much for watching. Please make sure to like the video and see you in the next math class. Goodbye.